All right, so here we have a gas loss question. We have a gas sample contained in a cylinder equipped with a movable piston occupied 300.0 milliliters at a pressure of 2.00 atmospheres. What is the final pressure if the volume increases to 500.0 milliliters? Right, there is a lot of information in here. You have to read through it and then circle which things you find important. Gas sample contained in a cylinder equipped with a movable piston occupied 300.0 milliliters. Occupied in milliliters. Oh, that's a hint for me that this is volume. So I'm just going to note that right there. At a pressure of 2.00 atmospheres. Oh, and this guy helped me out. He told me that this is a pressure. So I didn't even have to think about atmospheres and remember those are the units for pressure. What is the final pressure? That's what I'm looking for. If the volume increases to 500.0 milliliters. Okay, so it increases to that. So that means this is my ending volume, or V2. So this must be my starting volume, or V1. Notice I'm circling the words and I'm putting what they are regarding, pressure or volume. Now I'm going to rewrite that down there in my guess. What do I know as my givens? V1 is equal to 300.0 milliliters. P1, because that's the pressure at the start, is 2.00 atmospheres. V2 is 500.0 milliliters. What am I trying to find? Final pressure. So I'm trying to find P2. So I'm going to say P2 equals question mark. This way this gets everything organized so I don't miss anything. Equation. Okay, so for my equation for everything this week, you got to use that gas law triangle. Okay. So that triangle, sorry, let me slide this over. Pressure and volume are on the numerator. Temperature is on the denominator, or the bottom of the triangle. Okay. So what things am I talking about here? Only pressure and volume. So I'm going to use pressure and volume. Temperature wasn't mentioned at all, so I'm going to X off temperature. So my equation is P times V, because they're on the same line. P1 V1 equals P2 V2. You could also just have a whole list of the equations ready to go, but this is how you can remember what you're supposed to do with each one. Okay? P1 V1 equals P2 V2. So I'm going to write this one over here. And remember on the test when you're showing your work, if you put all this information in there, that gets what gives you your partial credit for that problem. Substitute is the S, P1, 2.00 atmospheres. So instead of saying P1, I'm going to be writing 2.00 atmospheres. And instead of saying V1, I'm going to be writing 300.0 milliliters equals P2. Oh, I don't know P2, so I'll just call it P2 times V2. V2 is 500.0 milliliters. Now this works because my units match. If they hadn't matched, I would have had to convert them when I was up here. P1 V1 equals P2 V2. So now I am going to combine my terms here. So 300 times 2, so that's 600 ATM milliliters. Don't forget about recopying your units. Equals P2 times 500.0 milliliters. All right, so now I'm closer, but my pressure is connected to this 500 milliliters. So it's connected by multiplication, so I'm going to divide. And what I do to one side, I'm going to do to the other side. And now I'll see I have milliliters in the numerator, milliliters in the denominator, so I can cancel. 500.0 milliliters in the numerator, 500.0 milliliters in the denominator, so they cancel. Okay, and so I'm going to rewrite here just so I can make sure I'm not missing anything. 600 atmospheres divided by 500.0 equals P2. So let me plug that into the calculator. 600 divided by 500. Okay. 600 divided by 500 gives me 1.2 atmospheres, a magnitude and a number. So this is my solve. So that's my second S, but I need 3 S's. Sig figs. 2.00 atmosphere, that's 3 sig figs, because zeros, when there's trailing and there's a decimal, are important. 300.0, 4 sig figs, because there's a decimal and they are trailing zeros. 500.0, 4 sig figs. So I have the choice of 3, 4, and 4 for my answer, and I always go with the least, so I need 3. So instead of 1.2, I'm going to have 1.2 atmospheres equals pressure 2. And that is my answer.